Okay. Yeah, hello students. Welcome to Diksha Karnataka YouTube channel. So in this session, I'm going to discuss the KCET 2024 Physics Answer Keys. Okay. So KCET has been done, right? I hope you guys have done well in the KCET Physics exam. Okay. So here, so let's discuss the answer key. Okay. Before that, so let's analyze the paper. Okay. So the first one here. Okay, so how easy or difficult was the paper? Here the paper difficulty level is moderate to difficult. Okay, so the spectrum lies between moderate to difficult. Okay, so how many questions were easy and how many questions were difficult? So total 11 questions were difficult. Okay, here total 11 questions were difficult, and the moderate questions, difficult questions means here the two or more than two concepts are involved. Okay, and 27 questions, in 27 questions it's just application based, that is you have to apply the formula. Okay, and then easy questions are 22 questions, right? So here these questions are memory based questions. Okay, yeah, and fact based questions. And the third one, how much an average student expect? Here average students can expect minimum 20 to 30 marks, okay, in the physics exam, because it's moderate to difficult level question paper, right? Yeah. And then yeah, next, were there any out of syllabus question? Yeah, actually in the physics paper there were total 3 questions from the out of syllabus. Okay, yeah, 3 to 4 questions are from deleted syllabus, right? Yeah. How much how was the paper in comparison to last year? So comparison, you cannot compare the last year paper to this year paper. Okay, pattern remains same. Okay, so but the difficulty level is moderate to difficult, right? Yeah. So were there any mistakes in the question paper? No, there is no mistakes. Okay, yeah. Next, do you think there is a change in pattern when checked in comparison with the last year's paper? No, there is no change in pattern. 60 questions, you have to do all the 60 questions in 1 hour, right? Do you think standards are being set higher? Yeah, actually standards are being set higher. So there is no previous year questions. Okay, if you compare with the previous year question papers, so very 3 to 4 questions are from previous year paper, that is repeated. Okay, those questions are repeated. Okay, yeah, standards are set little higher, okay, compared to the last year. Yeah. Okay, so let us discuss the every questions. Okay, so here I'm not going to discuss the whole solution. Okay, I will tell you how to solve the solution. Okay, how to solve the question, how to solve the question, and I will give you the correct answer. That's it. Okay, you have to do it. Yeah, the first one. Now, in Young's double slit experiment, an electron beam is used to produce interference fringes width beta 1. Here fringe width is beta 1 electron when the electron beam is used, right? Now the electron beam is replaced by a beam of proton with the same experimental setup. Okay, instead of electron they have used proton beam, right? And same speed. The beam of the proton is same speed. The fringe width obtained is beta 2. The correct relation between beta 1 and beta 2. The simple question, right? Here you have to use the de Broglie wavelength concept. Here there are two concepts are involved. One, the de Broglie wavelength, and another one, Young's double slit experiment, right? So here they have used electron beam, right? Isn't it? Wavelength of the electron is lambda. Okay, wavelength of the electron is lambda e. Wavelength of the proton is lambda p. Okay, you know that de Broglie wavelength, lambda is equal to h divided by momentum of the particle, right? H divided by momentum of the electron. Here h divided by momentum of the proton, right? So what is the momentum of the electron? Momentum of the electron is mass of the electron into velocity of the electron. Here momentum of the proton is mass of the proton into velocity of the proton. Here speed of the proton and electrons are same, right? But mass of the electron is lesser than mass of the proton, isn't it? If mass of here mass increases, lambda will be decreases, right? If mass increases, lambda will be decreases. So therefore fringe width when electrons beam is used is higher compared to the protons beam. Okay, protons beam used. Okay, so the correct option is D. Understood? Solve this, you will get the answer. D answer. Okay. Yeah. Next question. Question number 2. See here, the light energy E falls normally on a metal of work function E by 3. The kinetic energy K of the photoelectrons are. Apply photoelectric equation. Okay, so this question came from modern physics, dual nature of matter and radiation. Okay, so apply photoelectric equation. What is the photoelectric equation? Energy of the incident photon E equal to maximum kinetic energy of the photoelectron plus work function of the metal E naught, right? So what is the work function of the metal? E by 3, right? And energy of the incident photon is E. So maximum kinetic energy of the photoelectron is 2E by 3, right? Remember here, not all the electrons have the kinetic energy 2E by 3. Okay, so the maximum kinetic energy of the electron lies between 2E by 3 and 0. Okay, 0 and 2E by 3. So the correct option is C. Understood? Yeah. Next question, question number 3. The photoelectric work function for photometal is 2.4 electron volt. Among the 4 wavelengths, the wavelength of the light for which photo emission does not take place is. Okay, so this question came from again dual nature of matter and radiation, right? From the photoelectric effect, isn't it? Here, this one is the very easy question, right? So how to solve this? Here, the photoelectric work function of the photometal is given, right? That is 2.4 electron volt, right? So we need to find the correct wavelength. Okay, so correct wavelength, the wavelength of the light for which photo emission does not take place, right? So that is energy of the incident photon must be lesser than work function of the metal, right? So now apply this formula, E equal to hc by lambda. Okay, E equal to hc by lambda. So now put all the wavelength values. Okay, so for 700 nm you will get E equal to 1242 eV nanometer divided by 700 nanometer, right? Nanometer will get cancelled. So this will be almost 1.7 something, right? So the correct option is C. 1.7, 1.8 something. Okay, the correct option is C. For 700 nanometer, the photo emission does not take place. Yeah. The fourth question. In alpha particle scattering experiment, if V is the initial velocity of the particle, then the distance of closest approach is D. If the velocity is doubled, then the distance of closest approach becomes. Again, from which chapter this question came from? From atomic physics, right? Okay. Here, when the velocity of the alpha particle is V, the distance of the closest approach is D. If the velocity is doubled, what is the distance of closest approach, right? Isn't it? So at the distance of closest approach, here the alpha particle's kinetic energy becomes electrical potential energy. Okay, alpha particle's kinetic energy is equal to electrical potential energy. Okay, okay, here he has conserved angular momentum. Okay, this one is wrong. Okay, yeah, here kinetic energy half mv square is equal to electrical potential energy, right? That is kz e square divided by, here kz e square divided by r square. Okay, sorry, t square, d square. Okay, so now here distance of closest approach, sorry, this is just d only, not d square, d. Okay, yeah, so now d equal to here k z e square divided by half mv square. So distance of closest approach is inversely proportional to square of its speed, right? So now here the velocity becomes doubled, right? What is the distance of closest approach? Take the ratio, you will get the new distance of closest approach d dash equal to d divided by 4. Okay, so the correct option is D. Understood? Not C, D. Okay, next question, question number 5. The ratio of area first excited state to ground state of orbit of hydrogen atom is? The simple one, right? Direct question. Here you need to apply the formula, that's it. So we know that the radius of the nth orbit in the hydrogen atom Rn is directly proportional to nth square of the nth level of energy, right? nth energy level, right? We know that area is pi r square, right? So now A2 divided by A1 is equal to here, uh, here first excited state to the ground state, right? That is N2, N equal to 2 to N equal to 1, right? So this will be 2 squared, that is 2 to the power 4, right? 2 to the power 4 by 1 to the power 4. So this will be 16:1. Okay, so the correct option is D. R is directly proportional to N square, right? R square will be N to the power 4. So area is pi R square, right? So A2 by A1 equal to 2 to the power 4 by 1 to the power 4. That's it. Okay, yeah. Next question. Question number 6. The ratio of volume of aluminum 27 nucleus to its surface area is, here R naught value is given, that is empirical value, okay, 1.2 into 10 to the power minus 15 meter. Okay, how to solve this problem? We know that the volume of the nucleus V equal to 4 by 3 pi R cube, right? So volume to surface area, right? So which is equal to 4 by 3 pi R cube divided by 4 pi R square, right? So 4 pi will get cancelled. Here you will get R divided by 3, right? R is the radius of the aluminium, right? So this is the ratio. You know that R equal to R naught into A to the power 1 by 3. Okay, they have given capital R naught. I wrote small r naught. Okay, it doesn't matter. Yeah. So R equal to, substitute the R naught value. Okay, 1.2 into 10 to the power minus 15. Okay, substitute the R naught value, and A to the power 1 by 3, that is 27 to the power 1 by 3. Cube root of 27 is 3, right? Isn't it? Cube root of 27 is 3 divided by 3. So 3 will get cancelled. The remaining is 1.2 into 10 to the power minus 15 meter only. So the correct option is D. Okay. Yeah. This one is also almost direct question, right? Isn't it? Yeah. Next question. Question number 7. Consider the nuclear fission reaction. Consider the nuclear fission reaction. Here, neutron plus uranium 23592, barium 14456, krypton 8936, and 3 neutrons. Okay, assuming all the kinetic energy is carried away by the fast neutron. Red ink. Okay. Assuming the kinetic energy is carried away by the first fast neutron only, and total binding energies of uranium 23592, 14456, and krypton 8936, okay, to be 1800 mega electron volt, 1200 mega electron volt, and 780 mega electron volt respectively. The kinetic energy carried by each fast neutron is, again this one is also average kinetic energy carried by each fast neutron, right? Isn't it? So again this one is also direct question, right, from the nuclear physics, isn't it? Right? So the correct option is D. Okay, solve this, you will get the answer, and you will get the detailed solution, okay, in the description box. The link will be given in the description box. You can get the detailed solution. Okay, so here I am just discussing the answer key and the very brief solution. Okay, yeah. Next question. Question number 8. The natural logarithm of activity R of radioactive sample varies with time t as shown. At t equal to 0, there are n0 undecayed nuclei. Then n0 is equal to, okay, we need to find the value of n0. So what is the meaning of n0? n0 is the number of undecayed volume in the initial stage, right? That is at t equal to 0, isn't it? So here E square value is given. We know that activity R equal to R0 into e to the power minus lambda t, and n equal to n0 into e to the power minus lambda t. Okay, take antilog on both side, okay, or take log on both side. Okay, so then solve this. Here lambda is decay constant, t is time. Okay, so solve this, you will get the answer 75,000. Okay, again I am telling you, so try to solve this question, you will get the detailed solution, okay, which is the link is given in the description box. Okay, solve this, try to solve this, you will get the answer. Yeah. Next question. Question number 9. Depletion region in an unbiased semiconductor diode is a region consisting of Okay, so here depletion region in an unbiased semiconductor diode is a region consisting of, right, here neither free electron nor holes. Okay, neither free electron nor holes. This is the correct answer. Okay, ninth one, B. Okay, very easy question and memory based question. 10th one, the upper level of valency band and lower level of conduction band overlap in the case of silicon. Silicon is a conductor. Okay, valency band and conduction band do not overlap. Okay, both do not overlap. So sorry, both does not overlap. So here option A is wrong for semiconductor, silicon and germanium. Okay, now carbon is a conductor. No, carbon is not a conductor. Okay, some allotrope of carbons are carbon is conductor. Sorry, some allotropes of carbon are conductor. Okay, so carbon is not a conductor, it's an insulator. So option C is also wrong. So the correct option is B. Copper. Copper is a conductor, right? In conductor, valency band overlaps with the conduction band. Yeah. 11th one. In the diagram shown, Zener diode has reverse breakdown voltage of Vz. Okay, reverse breakdown voltage of Vz. Okay, the current through the load resistance RL is IL. Okay, the current through the Zener diode is, okay, we need to find current through the Zener diode, right, isn't it? See here, the load resistance and Zener diode both are in parallel, right? So that is at this point the current will divide, isn't it? At this point the current will divide. So what is the current through the Zener diode? We need to find the current through the Zener diode, that is Iz, right? Iz equal to, what is the potential difference across the Zener diode? That is V0 minus Vz, right? V0 minus Vz divided by Rs minus the current passing through the load, right? That is IL. Okay, so potential difference across the Zener diode divided by Rs. Okay, so the minus IL, that is equal to the current flowing through the Zener diode. Okay, so option D is the correct answer. Next question, question number. Okay, Harshvardhan is saying paper was JE level. No, paper is not JE level. Paper was not JE level. Okay, so it was bit lower level. Okay, lower level than the JE level. Okay, yeah. Next question, question number 12. PN junction diode is connected to a battery of EMF 5.7 volt. See, PN junction diode is connected to a battery of EMF 5.7 volt in series with resistance 5 kilo ohm such that it is forward biased. Okay, so this PN junction diode is forward biased if the barrier potential of the diode is 0.7 volt. Okay, so what is the potential difference across the PN junction diode then? It's 5 volt, right? 5.7 minus 0.7, right? Barrier potential, sorry, EMF of the battery minus barrier potential equal to potential difference across the PN junction diode, right? So that will be 5 volt. Neglecting the diode resistance, the current in the circuit. Okay, so now we got the value of potential difference across the PN junction diode, that is 5 volt. Okay, divided by 5 kilo ohm, that is 5 into 10 to the power minus 3. Sorry, 10 to the power plus 3. 5 will get cancelled. 10 to the power minus 3 ampere. 10 to the power minus 3 ampere is 1 milliampere. That's it. So option B is the correct answer. Okay, yeah, this one is also easy question. Okay, next one, a particle of mass 500 gram is at rest. It is free to move along the straight line. Okay, it is free to move along the straight line. The power delivered to the particle varies with time according to the following graph. Okay, we need to find power delivered to the power delivered to the particle varies with time according to the given graph. Okay, so the momentum of the particle at t equal to 5 seconds. Okay, at t equal to 5 seconds, we need to find momentum of the particle, right? Isn't it? Okay, so how to find the momentum of the particle? Power and time graph is given, right? Isn't it? So take the area of the power and time graph, right? First, area of the PT graph, okay, power and time graph, which gives us energy, right? Energy, isn't it? So energy E equal to P square divided by 2m. What is P? Momentum, right? P square divided by 2m. So now P equal to root of 2ma. That's it. Follow this method, you will get the answer C, 5 Newton second. Okay, yeah. Next question, question number 14. Dimension formula of the activity of radioactive substance. Very basic question and direct question. Okay, m to the power 0, l to the power 0 and t to the power -1. Okay, yeah. Next question, question number 15. An athlete runs along the circular track of diameter 80 meter. The distance traveled and the magnitude of displacement of the athlete when he covers 3/4 of the circle is in meter. Okay, so this is the complete circle, right? So let's say he starts from this point, point A. Okay, point A. Then he covers 3/4 of the circle, right? 3/4 of the circle. Okay, so we need to find magnitude of the displacement and distance, right? So what is the distance? Distance is the blue colored line, right? Or arc, isn't it? That is the distance, actual path taken by the object, right? And what is displacement? Displacement is distance between here, the shortest distance between these 2 points, right? A and B, right? That is the distance, displacement, magnitude of the displacement, right? So this is 40 meter and 40 meter, right? The diameter is 80 meter, radius is 40 meter, right? So what about this one? So this will be 40 into root 2 meter, right? So the displacement is 40 into root 2 meter, right? Directly you can select option A, right? Isn't it? And let's find distance also. Okay. So how to find the distance, right? Actual path taken by the this one, right? Object, right? Or athlete, right? So here 3/4 of the circle, right? So 3/4 arc, right? Isn't it? Arc of the whole circle, right? So arc length equal to 4/3 pi into r, right? Isn't it? So here 3/4 into pi into r, right? So 3/4 into pi into 40. Okay, solve this, you will get 60 pi. So option A is the correct answer, 60 pi and 40 into root 2 meter. Okay, yeah. Next question, question number 16. Among the given pair of vectors, the resultant of two vectors can never be 3 units. Vectors are, okay, you have to check each option. Okay, so check each option, you will get the answer D. Okay, here you have to check each options, that's it. Next question, question number 17. Okay, a block of certain mass is placed on a rough inclined plane. The angle between the plane and the horizontal is 30 degree. Here angle of inclination is 30 degree. The coefficient of static and kinetic friction between the block and the inclined plane are 0.6 and 0.5 respectively. Then the magnitude of the acceleration of the block is. Okay, we need to find magnitude of the acceleration of the block, right? Okay, let's check whether the block will move or not, right? So how to check? You remember angle of repose, right? So angle of repose tan theta is equal to coefficient of static friction mu s, right? Or mu, coefficient of friction mu, right? Isn't it? So what is the value of theta? 30 degree. Tan 30 degree is 1/√3. So 1/√3 equal to friction mu, right? Coefficient of friction mu. So mu equal to 1/√3. So 1/√3 is lesser than 0.6, right? So 1/√3 is lesser than 0.6. If coefficient of static friction here, so mu is 1/√3, right? Isn't it? So 1/√3 is greater than 0.6. Okay, so check, okay, check whether it is 1/√3 is greater than 0.6 or lesser than 0.6. Okay, so it is actually here this will be 1/√3, right? So what is 1/√3? 1/√3 is 1.7 something, right? Yeah, check this. Okay, so you will get which is greater than 0.6. Okay, so the correct answer is B. Okay, it will be 0 because block does not move. That's it. Okay. Next question, question number 18. A ceiling fan is around a fixed axle as shown. The direction of angular velocity along. Okay. So here the direction of the angular velocity, right? Okay, so what is angular velocity? Angular velocity V equal to R cross omega, right? Isn't it? Sorry, R cross angular velocity omega equal to, sorry, here angular velocity omega equal to r cross v, right? Isn't it? So apply right hand screw rule. Okay, so your tip of the fingers, first your tip of the finger directing towards r. Okay, your tip of the fingers directing towards r. Okay, this is the direction of the r, and curl your fingers, okay, towards v. So this is the direction of the v, right? Isn't it? Curl your fingers towards v. So what is the direction of the angular velocity? It is in downward direction, that is d. Okay, the correct option is d, not b. Sorry, not c. The correct option is d, minus k cap. Okay, yeah. Next question, question number 19. A body of mass 1 kg is suspended by a weightless string which passes over frictionless pulley of mass 2 kg as shown. Okay, so this is the pulley, mass of the pulley is 2 kg. Okay, as shown in the figure. The mass is released from a height of 1.6 meter from the ground. Okay, so this mass is released. Apply the conservation of lagging. Somebody said very bad key. Okay, शुरू से करना है. Okay, so how to solve this question, right? So apply conservation of energy theorem. Okay, conservation of energy theorem. So initial total energy equal to final total energy. What is the initial total energy? Initial total energy is potential energy of this block, right? Equal to final total energy is kinetic energy of this block plus kinetic energy, rotational kinetic energy of this block, right? So kinetic energy of the block half mv square plus kinetic energy of the rotational kinetic energy of this pulley, right? So that will be half I into omega square. Okay, half I into omega square. I is moment of inertia of the pulley, right? That is mr square, m into capital M into r square, right? Omega is v square divided by omega is v by r, right? Omega square will be v square by r square. So now substitute the values, you will get v equal to 4 meter per second. Okay, the correct option is D. Okay, substitute the values, you will get the answer. Okay, here we have to apply conservation of energy theorem. That's it, the direct question. Okay. Okay, another thing, why we are applying conservation of energy theorem. So here we are applying conservation of energy theorem because there is no external force acting on our system, right? So what is our system? The system is pulley and the block and string, right? Yeah. Next question, question number 20. What is the value of acceleration due to gravity at height equal to half the radius of the earth from its surface, right? Again, the direct question, right? Here we know that G dash equal to Gm divided by r plus h whole squared, right? So what is h? H equal to r by 2, right? Substitute the values, you will get G dash is equal to here G dash is equal to 4.4 meter per second square. Okay, h equal to r by 2, right? R plus r by 2 is 3r by 2, 3r by 2 whole square is 9r square by 4, right? So now 4 by 9 is 0.44. Okay, then gm by r square is g is 10, so 10 into 0.44 is 4.4. Okay, so the correct option is A. Understood? Yeah. Next question, question number 21. A thick metal wire of density rho and length L is hung from a rigid support. The increase in length of the wire due to its own weight is. Direct question from the NCERT, right? Very direct question from the NCERT. So we know that here the increase in the length of the wire to its own height, right? Own weight, isn't it? That is work done by the wire is equal to half into stress into strain, right? Half into stress into strain. Okay, So now apply the formula, you will get half rho g L square divided by y. Okay, half rho g L square divided by y. Direct question. Okay, 22. Water flows through a horizontal pipe of varying cross section at rate of 0.314 meter cube per second. So what is the rate? 0.314 meter cube per second, right? That is A1 into V1, right? Or AV, equation of continuity. You remember equation of continuity. The rate of flow is constant through one section to the other section, right? Okay, so this is A1 into V1. Okay, the velocity of the water at point where the radius of the pipe is 10 centimeter is. Okay, apply equation of continuity. Okay, so this is the pipe, right? So here the rate is 0.314 meter cube per second. So here you need to find the velocity of the liquid flowing out from the from this area, right? Cross sectional area, isn't it? Apply equation of continuity. A1 V1 is equal to A2 V2. So A1 V1 is given, A2 is given, right? How it is given? The radius of the pipe is given, right? Isn't it? So radius is pi r, okay, area is pi r square, right? So then you can easily find V2. V2 equal to A1 V1 by A2. Okay, A2 is pi r square, r is 10 centimeter. Okay, use the formula, you will get 10 meter per second. So the correct option is C. Okay, yeah. Next question, question number 23. A solid cube of mass m at a temperature theta naught is heated at a constant rate. It becomes liquid at temperature theta 1, right? A solid cube of mass m at temperature theta naught is heated at a constant rate. It becomes liquid at theta 1, right? Isn't it? So what is the heat supplied? So heat supplied Q equal to, first here m into here theta 1 minus theta naught, right? Isn't it? So the solid cube will about to start. Okay, solid cube, right? It will start to melt, right? Isn't it? So till that point the heat is here, this will be m into L F, right? LF is latent heat of fusion. Okay, and vapor at temperature theta 2, let S1 and S2 be the specific heat. Okay, sorry, here S1. Okay, S1 is the specific heat of the cube. Okay, m into S1 into theta 1 minus theta naught. Okay, plus m into LF. Yeah, so this is the phase where the cube is converted into liquid, right? Specific heats in its solid and liquid states respectively. If LF and LV are latent heats of fusion and vaporization respectively, then the minimum heat energy supplied to the cube until it vaporizes it. Okay, so now this is the phase where cube, that is solid, becomes liquid, right? So then liquid to vaporize, right? So that will be plus m into LV plus m into S2 into theta 2 minus theta 1. Okay, so this is the answer. So the correct option is C. Okay, the correct option is C. Okay, next question, right? So how it is minus K, right? So which one? I think you guys are talking about this question, right? This question, right? So R is along x-axis, right? So this is the direction of the speed, right? Or velocity, right? V vector, isn't it? So apply right hand screw rule, right? Here first tip of the fingers directing towards R, right? And then curl towards V. So then omega is in negative Z direction, that is minus K cap, right? So Z here, the upward direction is positive, right? Isn't it? Yeah. Next question. Okay, what we were discussing? Okay, we were discussing this one, right? Yeah, option C is the correct answer. Next one, question number 24. 1 mole of an ideal monoatomic gas is taken round the cyclic process MnOM. The work done by the gas is, the simple one. Okay, work done by the gas is area under the curve of P versus V graph. Okay, so what is the work done by the gas? Work done by the gas is area of this triangle, right? So that will be 2 PV naught. Okay, correct option is D. Take the area of this graph. Okay, we will get 2 P naught V naught. Yeah. So next, 25th, right? So the ratio of the molar specific heats of oxygen is direct, right? So oxygen is diatomic molecule or monatomic molecule? It is a diatomic molecule, O2, right? Isn't it? So ratio of the specific heats, that is Cp by Cv, right? So what is the value of Cp for oxygen? It is 7 by 2. For okay, what is the value of Cv for oxygen? 5 by 2. So solve this, you will get 1.4. So the correct option is A. Okay, yeah, okay, yeah. Next question, question number 26. For a particle executing simple harmonic motion at its mean position, velocity is 0 and acceleration is maximum. Absolutely wrong. So at its mean position, velocity is maximum, acceleration is 0. Okay, so the correct option is B. Again, the direct question. Okay, if you have derived the simple harmonic motion, okay, equation, okay, so if you remember it, you can easily solve this question, right? There is nothing to solve, it's direct question. So question answer is B. Yeah. Question number 27. A motorcyclist moving towards a huge cliff with a speed of 18 km per hour. Okay, so motorcyclist moving towards a huge cliff. Okay, 18 km per hour. So you have to convert this into meter per second. Okay, so this will be 5 meter per second. Okay, 18 into 5 by 18. 18 will get cancelled. 5 meter per second. Okay, blows a horn of source frequency 325 hertz. If the speed of the sound in air is 330 meter per second, the number of beats heard by him. Okay, again the direct question, right? Isn't it? So apply. So this is from the Doppler's effect. Okay, so now the apparent frequency f dash is equal to f into here velocity of the sound in air, right, divided by here velocity of the sound in air minus velocity of the sound or velocity of the source. Okay, so what is the velocity of the source? 5 meter per second. This is Vs, right? So what is F? 325. What is Va? 330. Here Va is 330. So 330 by 325 into 325. 325 will get cancelled. The answer will be here 330, right? We need to find the beats, right? Isn't it? So beats is here F2 minus F1. So that is 330 minus 325. You will get the answer 5. So the correct option is A. Okay, understood? So first find F2. So this is F2. F dash is F2. Okay, we need to find the beats per second, right? So now take the difference between F2 and F1. We will get the beats. Number of beats heard by him, right? Okay, here we need to find number of beats heard by him. Okay, so that is F2 minus F1, which is equal to 5. Okay, number of beats heard by him. Okay, yeah. Next question, question number 28. A body has charge of minus 3.2 microcoulomb. The number of excess electrons it has is. Okay, so in every videos, I mean in previous videos, I have given so much stress to this concept, right? That is properties of the charges. See, every time they ask properties of the question from the properties of the charges, right? So here, which concept you have to apply? Here you have to apply quantization of the charge. That is Q equal to N into E. The value of the Q is given, right? Take the magnitude of the this one, minus 3.2 microcoulomb, that is 3.2 microcoulomb, that is 3.2 into 10 to the power minus 6 coulomb, equal to N divided by E. E is 1.6 into 10 to the power minus 19. Okay, so now solve this, you will get the answer 2 into 10 to the power 13. Okay, yeah. Question number 29. A point charge A of 10 microcoulomb and another point charge B of plus 20 microcoulomb are kept 1 meter apart. Okay, here 10 microcoulomb and 20 microcoulomb are kept 1 meter apart. Okay, the electrostatic force on A due to B is F1. Okay, electrostatic force on A due to B is F1, right? So what is the electrostatic force on B due to A1? So that will be F2, right? Isn't it? F2. Then we need to find the relation between F1 and F2, right? Here the force on A due to B is same as force on B due to A, action reaction pair, right? Isn't it? So the correct answer is F1 vector equal to minus F2 vector. The direct question, right? Again, I have given so much stress to Coulomb's law in vector form, right? See, the questions came, right? The question came, right? Isn't it? So the correct option is B. Yeah. Next question, question number 30. A uniform electric field E equal to 3 into 10 to the power 5 Newton per Coulomb is acting along the positive y-axis. The electrostatic flux or electric flux through rectangle of area 10 centimeter into 30 centimeter, 10 centimeter cross 30 centimeter, whose plane is parallel to the zx plane. Okay, so let us draw the diagram. Okay, so this is z-axis, x-axis and y-axis. Okay, so this is the rectangle, 10 centimeter cross 30 centimeter rectangle. Okay, and the electric flux is along y-axis, right? So what is electric flux? Electric flux phi equal to E dot A, right? Isn't it? So does E and A both are in same direction? Yeah, right? The here the direction of the A is same as the direction of the magnetic field, sorry, direction of the electric field, right? Isn't it? Here the electric field is passing through this rectangle, right? Isn't it? That is, here the electric field is perpendicular to the plane of this rectangle, right? So phi equal to E dot A. So in scalar, Ea cos theta. Theta is angle between E and A, that is 0 degree. You know the value of E, you know the value of A. Solve this, you will get the answer 9 into 10 to the power 3 volt meter. Okay, 9 into 10 to the power 3 volt meter. Yeah. Okay, understood? Yeah, next question. Question number 31. The total electric flux through a closed spherical surface of radius r enclosing an electric dipole of moment 2aq is. Okay, again the direct question, right? They are asking total electric flux, right? Not electric field. Remember, electric flux. Here minus q charge plus q charge separated by a distance 2a. Okay, so we need to find total electric flux. Here this is the dipole enclosed by a sphere, okay, or spherical surface. Okay, the radius of the spherical surface is r. Okay, so what is the total electric flux? Total electric flux will be 0, right? Isn't it? So what is the total electric flux? Total electric flux equal to charge enclosed divided by epsilon naught. What is the total charge enclosed or net charge enclosed? 0, right? Plus q minus q is 0, right? So flux is 0, but electric field is not 0. Remember, electric field is not 0, flux is 0. So option A is the correct answer. Okay, and the other thing, if the total charge is 0 inside the surface, any closed surface, electric field does not need to be a 0. Okay, understood? Yeah, the electric flux is 0. Next question, question number 32. Under the electrostatic condition of a charged conductor, which among the following statements is true? Again, the direct question. Okay, so option C is the correct answer. Any excess charge inside on the surface of the conductor, right? So that is the answer. Option C. Option A, B, D are wrong. Okay, yeah. Next question, question number 33. A cube of 1 centimeter contains 100 molecules, each of having an induced dipole moment of 0.2 into 10 to the power minus 6 coulomb meter in an external electric field of 4 nanocoulomb. The electric susceptibility of the material is. Again, the direct question. Okay, so you know the formula, right? Electrical susceptibility. Apply the electrical susceptibility formula. Okay, you will get the answer phi. Xi equal to phi. Okay, direct question, for direct formula based question. Yeah. Next one, 34. A capacitor of capacitance 5 microfarad charged by a battery of EMF 10 volt at an instant of time. The potential difference across the capacitor is 4 volt. Okay, and the time related of change of potential difference across the capacitor is 0.6 volt per second. Then the time rate at which energy is stored in the capacitor at that instant. Again, so here this one is little bit trickier, right? How to solve? We know that energy stored in the capacitor is half CV square. So at any instant we need to find the energy stored in the capacitor, right? How? differentiate E with respect to t. So dE by dt equal to 2 by 2 into Cv into dV by dt, right? 2 will get cancelled. Now substitute the given values Cv and dV by dt. dV by dt is 0.6 volt per second, right? So apply the given values, you will get 12 microwatt. Okay, 12 microwatt. So that is they are asking the power, right? Yeah. Next question, question number 35. E vector is the electric field inside the conductor whose material has conductivity sigma, resistivity rho. The current density inside the conductor is J vector. Okay, so what is current density? Current density J vector is equal to I divided by A vector, right? The current form of Ohm's law. Okay, so the current form of Ohm's law is here E equal to here what is rho? Resistivity into the this one, right? The current density, right? Rho into J vector, right? Isn't it? So the correct option is C. Okay, the direct question. Next one, 36 one. In the circuit shown, the end A is at potential V naught. Here end A is at potential V naught and end B is ground. The electric current I indicated in the circuit is. Okay, so here we need to find electrical current, right? So okay, how to solve this, right? So we have to redraw this diagram, right? The circuit diagram, right? Isn't it? So this one is balanced Wheatstone bridge and this one is balanced Wheatstone bridge, right? So here I will write, I will draw the circuit diagram and then you have to solve it. Okay, so here this is point A, right? Let's say this point is B. Okay, so point B, okay, let's say this point is okay B only. This point B is connected to one resistor, this resistor. Okay, here the point is C. Okay, the point C connected to this resistor, right? Yeah, so now again the point A, here this point A connected to this resistor, right? This one, right? And then here the point is D. Okay, so now the point C, right? So this is point D. Okay, now point D is connected to this resistor, right? Isn't it? The point D connected to this resistor, right? And let's say this point is E. Okay, now here the E is connected to C, right? Yeah, E is connected to C. R, 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 R and R. So now take the ratio, R by R is 1, R by R is 1. So this is balanced Wheatstone bridge. So you have to neglect this arm, right? Similarly, you have to draw this circuit diagram, okay, like this, 2R, then 2R, right? And then 2R, and then 2R. So neglect this branch, right? Why we are neglecting this branch? Because the ratio is same, so potential difference will be 0, right? The potential difference will be 0. Why potential difference is 0? Because potential at C and D both are same, right? So you have to neglect this branch also, right? So now you need to find current I, right? So that one you need to find. So the value of I equal to V naught divided by 3R. Okay, value of I equal to V naught divided by 3R. Okay, option D is the correct answer. Yeah, next question, question number 37. Okay, so here the electric current flowing through a given conductor varies with time as shown in the graph below. Okay, I versus T graph is given, right? The number of free electrons which flow through the given cross section of the conductor in the time interval. Okay, we need to find number of electron passes through the given time, right? Isn't it? So what is I? I equal to rate of flow of charge, right? That is N into E divided by T, right? N into E by T. So what is N? N equal to I into T divided by E, right? Isn't it? So that is, you need to find area under this graph. Okay, first find area under this graph Okay, area under this graph between 0 to 20 second, right? Area under this graph, find area under this graph and then divided by the charge of the electron, that is 1.6 into 10 to the power minus 19 coulomb, right? So now you will get, I think you will get, yeah, A, answer A. Okay, 3.125 into 10 to the power 19. Okay, this is the number of electron which is passing through the cross section of the conductor. Okay, option A is the correct answer. Okay, yeah. Next question, question number 38. The IV graph for a conductor at two different temperatures, 100 degrees Celsius and 400 degrees Celsius, is as shown in the figure. The temperature coefficient of resistance of conductor is about, okay, we need to find temperature coefficient, right? So that is, we need to find the value of alpha, right? So how to find the value of alpha? I versus V graph is given, right? Find the slope. What is slope? Here the slope tan theta equal to slope, right? That is R, right? Isn't it? Sorry, here this will be 1 by R. I versus V graph is, if you take the slope of I versus V graph, we will get the 1 by R, right? So then you will get the resistance R, right? Isn't it? Take the slope, you will get the resistance R, then apply this formula, R equal to R naught into 1 plus alpha into delta T. Okay, alpha is temperature coefficient. Okay, resistance of the temperature coefficient. Okay, so you will get the answer option A, 3 into 10 to the power minus 3. Okay, 38th one is the correct option for 38th one is A. Okay, understood? Yeah. Question number 39. An electric bulb of 60 watt 120 volt is to be connected to 200 volt source. What is the resistance to be connected in series with the bulb so that the bulb glow properly, right? So first find the resistance of the bulb, right? Isn't it? Right? So sorry, first find the current flowing through the bulb. Okay, so then you can easily find the resistance to be connected in series with the bulb, right? Isn't it? First find the current flowing through the bulb, then you can easily find the resistance should be connected in series with the bulb. So the correct option is C. Okay, that is the method. Follow the method, you will get the answer. Okay, almost direct question. Okay, yeah. Question number 40. Okay, meter bridge. So this one is out of syllabus. Okay, in an experiment to determine the temperature coefficient of resistance of a conductor, a coil wire X is immersed. Okay, okay, what they are asking? Ram asking only answers. So yeah, here I am discussing only answers. Okay, not whole solution. Okay, so whole solution will be given. Okay, or it will be so the whole solution is given in the description box. Okay, yeah, nahi hai. Okay, yeah, whole solution will be given. Yeah, fine. In an experiment, determine the temperature coefficient of resistance of a conductor. A coil of wire X is immersed in a liquid. It is heated in an external agent. A meter bridge setup is used to determine the resistance of the coil X at a different temperatures. Okay. The balance points measured at temperature T1 equal to 0 degrees Celsius, T2 equal to 100 degrees Celsius are 50 centimeter and 60 centimeter respectively. If the temperature resistance taken out is S equal to 4 ohm, in both trials, the temperature coefficient of the coil is. Again, here it is a medium level question. Okay, medium question. Okay, here difficulty level is medium. Apply this formula, R2 divided by R1 is equal to X divided by 100 minus X. Okay, first apply this formula, you will get the resistance value. Okay, and then you know that the resistance R equal to R naught into 1 plus alpha into delta T. So this is the variation of the resistance with the temperature, right? So then apply this formula. Okay, so first apply this formula, you will get the resistance. Okay, at temperature this one 0 degrees Celsius and 100 degrees Celsius. From that you will get the answer alpha. Okay, so the option C is the correct option. Okay, correct option is C. Question number 41. A moving electron produces both electric and magnetic field. Direct question. Okay, yeah. Question number 42. A coil having 9 turns carrying current produces magnetic field B1 at the center. Okay, so this is the coil, okay, having 9 turns, and it produces the magnetic field B1, right? So what is the current magnetic field produced by the coil? The magnetic field produced by the coil, your B equal to mu naught into Ni divided by 2R. Okay. Now the coil is rewounded into 3 turns, carrying same current. Then the magnetic field at the center B2 is, see here, now the coil is rewounded into 3 turns, okay, and carrying the same current. Then the magnetic field at the center, right, we need to find. So now apply the same formula for the second case, okay. So then take the ratio, you will get the answer A equal to B1 by 9, okay. A equal to B1 by 9. Answer A is the correct, option A is the correct option, okay. B1 by 9, option A is correct. Next one, 43. A particle of specific charge Q by M equal to pi coulomb per kg is projected from the origin towards positive x-axis with the velocity 10 meter per second. Okay, so velocity is given, specific charge is given, right? In a uniform magnetic field B vector equal to minus 2k cap Tesla, the velocity V vector of particle after time t by 12 second will be. Again, the direct question, right? So, sorry, not direct question. This is a difficult question, okay. Yeah, so the velocity is 10 meter per second, right, isn't it? And the magnetic field vector is also given, right? So you need to find velocity of the particle after time t equal to 1 by 12 second, right? Here, when you throw the particle at an angle theta, right, isn't it? So this is z axis, okay. Okay, let's say this is z axis. So magnetic field is B vector, which is equal to minus 2k cap Tesla, right? And velocity is 10 meter per second, right? And specific charge is given, right? So you need to find velocity after 1 by 12 second, right? So when you throw the velocity, when you throw the particle in a uniform magnetic field at an angle theta, okay, right, at an angle theta with the magnetic field, right? So at an angle theta with the magnetic field like this, right, isn't it? Sorry, not like this, okay, sorry, here this way, at an angle theta with the magnetic field. Okay, let us take this axis only, this as the z axis only, this will be very convenient to solve that. So okay, so this is magnetic field, okay, theta with the magnetic field, okay. So this is z and minus z, right? So what happens? It will take helical path, right, isn't it? We need to find velocity v vector particle after time t equal to 1 by 12 second, right? So we know that here the velocity v equal to qbr divided by m, right, isn't it? Right? So we need to find after 1 by 12 second what is the velocity, right, isn't it? So then you have to use that formula, 2 pi divided by 2 pi m divided by qbr, right? So use those formulas, okay. You will get v vector equal to 5 into root 3 I cap plus j cap, okay. So the correct option is D, okay. Use those formulas, you will get the answer. Next question, question number 44. The magnetic field at the center of a circular coil of radius r carrying current I is 64 times the magnetic field at the distance x on its axis from the center of the coil, okay. So this is the magnetic coil, the radius of the coil is r, okay, carrying current I is 64 times, yeah, this is I, okay, 64 times the magnetic field at the distance x, its axis from the center of the coil, okay. So this is the magnetic field at the center of the coil, so this is B, C, okay. So this is I dash, this is point X, okay. So this will be I dash and the radius is R, right? So now write the expression of the magnetic field at this point P, due to this circular coil, okay, and magnetic field at the center of the coil. They have given the current also, right? Isn't it? Write the expression. You will get the value of x as r into root 15. Okay, r into root 15. Option D is the correct answer. Okay, option D is the correct answer. Understood? Write the expression, you will get the answer. You have to take the ratio. That's it. Okay. Yeah. If you know the expression, that's it. Otherwise, you have to derive it. Right? Yeah. Next question, question number 45. A magnetic hysteresis is exhibited by dash magnetic material. Again, the direct and memory based question, right? It is for both para and ferromagnetic material. Okay. Option D is the correct answer. From the magnetism. This question came from magnetism chapter, right? Yeah. Question number 46. Magnetic susceptibility of Mg at 300 Kelvin is 1.2 into 10 to the power minus 5, right? What is its susceptibility at 200 Kelvin? So again, see here, if you notice that, so they have asked a lot of ratio type of question, right? Isn't it? So magnetic susceptibility xi is directly proportional to 1 by T or inversely proportional to the absolute temperature T, right? So now magnetic susceptibility of the Mg is given, right? At 300 Kelvin, and you need to find susceptibility xi at 200 Kelvin, right? Take the ratio, you will get the answer xi dash equal to 1.8 into 10 to the power minus 5. Okay, so the correct option is C. Understood? Yeah. Next question, question number 47. Okay, a uniform magnetic field of strength B equal to 2 millitesla exits vertically downward. Okay, so here the magnetic field 2 millitesla exits vertically downward. This magnetic field lines passes through the closed surface as shown in the figure. Okay, the closed surface consists of hemisphere. So this is hemisphere S1. Okay, right circular cone S2. So this surface area is S2 and the hemispherical surface area is S1, and circular surface S3. Okay, and circular surface, so this one is S3. Okay, this surface area is S3. The magnetic flux through S1 and S2 respectively. Again, the direct question, right? How do you solve the magnetic direct and bit tricky question? Okay, so what is the magnetic flux through this surface, right? S1 and S2, right? Isn't it? That is equal to magnetic flux passing through S3. That's it, isn't it? So magnetic flux passing through S3 is equal to S1 and S2, right? So okay, so I will redraw the diagram. So this is from this view. Okay, from this view, this is how does the diagram looks like. Okay, so this is the direction of the magnetic flux, right? Isn't it? So magnetic flux passing through this surface area, right? This circular surface area S3, right? Isn't it? Right? So magnetic flux passing through S1 and S2 is same as S3, right? So what is magnetic flux? Magnetic flux phi is equal to B dot A, right? Isn't it? So what is for S1? In S1, the magnetic flux is moving in, right, or moving inward, right, or moving into the this surface area, right? Isn't it? A and B both are in opposite direction, so magnetic flux will be negative. So for the second surface, that is S2, A and B both are in same direction, so magnetic flux is positive, right? So apply this formula here, phi equal to BA cos theta, right? Apply this formula, you will get the answer minus 20 microweber and plus 20 microweber. So the correct option is A. Okay, yeah. Next question, question number 48. In the figure, conducting ring of certain resistance is falling towards a current carrying straight long conductor. The ring and conductor are in the same plane, then the induced electric current is 0. Okay, so we need to find induced current, right? I mean, not exactly, you need to find in which direction induced current produces, right? Yeah, the concept based question, right? So here this is the current carrying long wire and the direction of the current is towards right. Now apply right hand screw rule or right hand thumb rule, right? So your tip of the fingers represents the direction of the magnetic field, right? So the direction of the magnetic field at this point or this point or this point is outward from the plane, right? Outward from this board, right? And magnetic field varies as you move away from the wire, right? Magnetic field varies as you move away from the wire. So here the circular loop is falling down towards wire, right? That is, magnetic field increases or magnetic flux passing through the coil increases, right? So now you have to apply Lorentz law, right? Isn't it? So that is, to oppose the increase in magnetic flux, what happens? Induced current will be produced in such a way that it opposes that increase in magnetic flux, right? So what is the direction of the induced current? The direction of the induced current will be in clockwise direction, right? It will be in clockwise, right? Isn't it? So this is the direction of the increase in magnetic flux, right? So what is the opposite of the increase in magnetic flux? This way, right? Into the plane, isn't it? So now apply right hand thumb rule. Here the direction of the current has to be in clockwise, right? So induced electric current is clockwise. Option C is the correct answer. Yeah. Next one, question number 49. An electric current of 2 ampere flows through a coil. The resistance of the coil is 10 ohm. What is the change in magnetic flux associated with the coil in 1 millisecond? So again, this one is direct question, right? So we need to find change in magnetic flux associated with the current. Associated with the coil in 1 millisecond, right? So induced current I equal to induced EMF produced in the coil divided by resistance of the coil, right? You have to apply this formula, right? And then you need to find here d phi, right? What is induced EMF? Induced EMF is rate of change of magnetic flux. So I equal to d phi by dt. I am writing in magnitude, so d phi by dt by r, right? So now d phi by dt equal to I into r, right? dt is 1 millisecond. You can easily get the value of d phi. So d phi equal to I r into 10 to the power minus 3 second, right? So now substitute the values of I and r. You will get the answer 2 into 10 to the power 2 minus 2 Weber. Okay, 2 into 10 to the power minus 2 Weber. 2 into 10 to the power minus 2 Weber. That is the change in magnetic flux. So option B is the correct answer. Okay. Yeah. Next question. Question number 50. Okay. A square loop of side length A is moving away from an infinitely long current carrying conductor at a constant speed V. So this is the square loop. Side of the square loop is side length of the square loop is A. So this is moving towards right with velocity V. Okay, and the current is in upward direction. The current is I. Let x be the instantaneous distance between long conductor and side AB. Okay. Let x be the instantaneous distance between long conductor and distance AB. Okay, so this one. The mutual inductance M of the square loop conductor pair changes with time t according to which of the following graphs? Okay, we know that the relationship between Mi and phi, right? So Mi equal to n into phi, right? As the loop moves away from the conductor, what happens? The flux through this loop changes, right? It decreases. As you move away from the current carrying conductor, what happens? Magnetic field decreases. That is, the flux through this square loop decreases, right? So Mi equal to n into phi, right? So now differentiate both sides with respect to t. Now differentiate both sides with respect to t. So m into di by dt, right, which is equal to n into d phi by dt, right? So here the mutual inductance is inversely proportional to time, right? So from this we can conclude that mutual inductance is inversely proportional to time. So what is the graph? The graph will be the L-shaped graph, right? The curve graph, right? So option A is the correct answer, not linear graph C, B and D. Okay, so the correct option is A. Question number 51. Which of the following combination should be selected for better tuning of an LCR circuit used for communication? Okay, so here better tuning circuit has high quality factor. Okay, better tuning circuit has high quality factor, high Q factor, right? RLC are given, right? So we know quality factor Q equal to in terms of RLC, right? So quality factor Q equal to 1 by R into root of L divided by C. Okay, so now you have to check each option. Okay, so here check the each option. Okay, in option D, R equal to 15 ohm, L equal to 3.5 Henry, C equal to 30 microfarad. Okay, if you substitute the values, you will get the highest value of quality factor. Okay, so option D is the correct answer. Here you will get larger value or high value of the quality factor. Okay, next one, question number 52. In an LCR series circuit, the value of only capacitance C is varied. The resulting variation of resonance frequency F0 as a function C can be represented as. Okay, here we need to find the correct graph between frequency, the resonant frequency, and C, right? The capacitance. We know that capacitive reactance Xc equal to 1 divided by C. Sorry, Xc equal to 1 divided by omega C, right? Isn't it? So here omega is 2 pi f, right? 2 pi f naught, right? And 1 divided by 2 pi f naught into C, right? That is Xc, right? So from this I can conclude that f naught is inversely proportional to C, right? So the graph will be the curved graph, L-shaped graph, right? So the correct option is C. Okay, again direct question, right? Question number 53. The same topic, same type of question, right? Isn't it? So the figure shows variation of R, XL and XC with the frequency F in series LCR circuit. Then for what frequency is the circuit capacitive? Okay, if the circuit is capacitive circuit, okay, capacitive, then XC is greater than XL. Okay, XC is greater than XL. So at frequency A, okay, here at frequency A, see, at B, Xc equal to XL, right? Here it is intersecting, so it is resonant circuit, right? So at C, Xc is lesser than XL, so it is inductive circuit, right? Isn't it? So at A, the frequency A, the circuit behaves like a capacitive circuit. Okay, so option C is the correct answer. Understood? Yeah. Next question, question number 54. Electromagnetic waves are incident normally on a perfectly reflecting surface having surface area A. Okay, here, okay, electromagnetic waves are incident normally on a perfectly reflecting surface having surface area A if I is the intensity of the incident electromagnetic radiation and C is the speed of light in vacuum. The force exerted by the electromagnetic wave on reflecting surface is, again, medium level question, right? Isn't it? So here you know that force F equal to rate of change of momentum, right? Rate of change of momentum, dp by dt, right? Or delta p by delta t, right? So what is the change in momentum? Here this is the surface area, right? So electromagnetic wave incident on the surface area, right? And then it will reflect, perfectly reflecting surface area, right? Isn't it? That is, when it falls on this surface area, what happens? It will reflect, right? So what is the change in momentum? Change in momentum is 2p, right? 2p. So what is momentum? Ia by c. That's it. So force exerted by this electromagnetic wave on the surface area, perfectly reflecting surface area, is 2Ia by c. That's it. Okay, so the correct option is A. Momentum is Ia by c, so change in momentum is 2p, right? Yeah. Next question, question number 55. The final image formed by an astronomical telescope is, okay, final image formed by an astronomical telescope is virtual, inverted and magnified. Okay, option D is the correct answer. Direct question. Okay, virtual, inverted and magnified. Okay, next one, question number 56. If the angle of minimum deviation is equal to angle of prism for an equilateral prism, then the speed of the light inside the prism is, First find the refractive index of the prism, right? So you know that refractive index is ratio of the speed of the light in vacuum to the speed of the light in medium, right? So how do you find the refractive index of the prism? You know the formula, mu equal to sine of A plus delta m. Delta m is angle of minimum deviation divided by 2 divided by sine of A by 2, right? So what is the angle of minimum deviation? Here the given prism is equilateral prism, right? That is angle of prism is 60 degree, right? Here according to the question, angle of minimum deviation is equal to angle of prism, that is A equal to delta m, right? A is 60 degree, delta m is 60 degree, right? So now substitute the values, you will get mu equal to root 3. Okay, 60 plus 60, 120, 120 by 2 is 60, sine 60 degrees root 3 by 2. Here sine 30 degrees 1 by 2, 1 by 2, 1 by 2 will get cancelled, the remaining is root 3, right? Okay, we got the value of mu, right? So then substitute this formula, okay, apply this formula, mu equal to C by V, refractive index formula, the ratio of the speed of light in vacuum to the speed of light in medium. Okay, you will get root 3 into 10 to the power 8 meter per second. Okay, yeah. Next question, question number 57. A luminous point object O is placed at a distance 2r from the spherical boundary separating two transparent media of refractive indices n1 and n2 as shown, where r is the radius of curvature of the spherical surface. N1 is equal to 4 by 3, n2 equal to 3 by 2, and r equal to 10 centimeter. The image is obtained at a distance of p equal to. Okay, we need to find image obtained image from the p, right? Distance of the object from the distance of the image from the p, right? So which formula you have to apply? We have to use here the formula n2 divided by v minus n1 divided by u equal to n2 minus n1 divided by r, right? Apply this formula, okay, you will get the answer 30 centimeter from the rarer medium. Okay, the value of n2 is given, n1 is given, r is also given, right? Substitute the values, that's it. Okay, o is also given, object distance, right? You need to find the v value, that's it. Okay, yeah. So what is u? U is 2r, minus 2r. Okay, yeah. Next question, question number 57. Okay, question number here 58. An equiconvex lens of radius of curvature 14 centimeter is made up of two different materials. Left half and right half of vertical portion is made up of material of refractive index 1.5 and 1.2 respectively, as shown in the figure. If a point object is placed at a distance of 40 centimeter, calculate the image distance. Okay, so here this equiconvex lens made up of two different materials of refractive index 1.5 and 1.2, right? So object placed at 40 centimeter from this equiconvex lens. We need to find the final image, right? Final image distance, right? Okay, so how to solve this one, right? So we usually solve the question where the equiconvex lens is made up of same material, both sides are same material, right? Here the different materials, right? Isn't it? So apply lens maker's formula. Here the lens maker's formula is 1 divided by f equal to mu minus 1 into 1 divided by r1 minus 1 divided by r2, right? Apply this formula for both sides. Okay, so then you will get the two focal lengths, 1 by f1 and 1 by f2, right? So then find the equivalent focal length. How do you find the equivalent focal length? So 1 divided by f equal to 1 by f1 plus 1 by f2. Okay, so how do you solve this question? First apply lens maker's formula for both materials, okay, and then find equivalent focal length. Okay, so you got the equivalent focal length, right? So then apply lens formula. So 1 divided by f is equal to 1 by v minus 1 by u. Okay, then apply lens formula. So here you will get option, okay, 40 centimeter. Okay, final image distance 40 centimeters. So option D is the correct answer. Understood? Yeah. Next question, question number 59. Okay, so it looks like the Doppler effect, right? Isn't it? Actually, this is out of syllabus, they are given. Okay, let's solve. Here galaxy is moving away from the earth, so that the spectral line at 600 nanometer is observed at 601 nanometer. Then the speed of galaxy with respect to the earth is. So how do you solve? Here we know that the speed of the galaxy, right, delta V with respect to the Earth divided by c equal to delta lambda divided by lambda. So delta V is equal to c into delta lambda divided by lambda. So delta V equal to, here c is speed of light in vacuum, right, that is 3 into 10 to the power 8 into delta lambda. Delta lambda is 601 minus 600, that is 1 divided by 600, right, 1 divided by 600. So this will be 200, right. 1 by 200 is 1 by 2 is 0.5, 1 by 100 is 10 to the power minus 2, so 0.5 into 10 to the power minus 2 is 5 into 10 to the power minus 3, right. So now delta V is equal to, solve this, you will get 500 kilometer per second, okay, 500 kilometer per second. So the correct option is A, okay. So this is out of syllabus question, okay. Next question, question number 60. Okay, okay, these kind of question you guys have solved, right? In mock test also we have given these kind of question. Yeah, 3 polarized sheets are coaxially placed as indicated in the diagram. Pass axis of the polarides 2 and 3 make 30 degree. Here this makes 30 degree and 90 degree. Okay, this makes 90 degree with this one, right? Sorry, with respect to this one, isn't it? 90 degree with respect to this one. Yeah. Of polarized sheet 1, if I naught is the intensity of the incident polarized light entering sheet 1. Okay, I naught is the intensity of the polarized sheet 1, right? When it passes through the polarized P1, the intensity will be I naught by 2. Okay. The intensity of the emergent light through the sheet 3. Okay. So here the intensity after it passes through the first polaroid is I naught by 2. So then intensity of the light when it passes through the second polaroid, right? Apply Malus law. Here the Malus law will be I equal to here I naught by 2 into cos square theta, right? See, theta is 30 degrees, so cos square 30 degree. So cos square 30 degrees 3 by 4. So I equal to I naught by 2 into 3 by 4, right? So then it passes through the third sheet, right? So we need to find the final intensity, that is the intensity of the light wave after passing through the third sheet, right? So again apply Malus law, right? So what is the intensity here? So I dash is equal to, here I naught, okay, I will write it down here, okay, the final intensity value I dash is equal to, here I naught by 2 into 3 by 4, that is 3 I naught by 8, 3 I naught by 8 into cos square theta. So what is the value of theta here? The theta is 60 degree, right? Isn't it? 90 minus 30, isn't it? With respect to the second one, here the pass axis, this one is 30 degree, sorry 60 degree, right? 90 minus 30 is 60 degree, isn't it? So this will be 60 degree, cos square 60 degree. So what is the value of cos square 60 degree? 1 by 4, right? So 3 I naught by 8 into 1 by 4 is 3 I naught divided by 32. Okay, that's it. So the correct option is B. Okay, yeah, okay, that's it. So these are the given answer keys, okay, and these are the correct answer keys, okay, understood? So if you have any doubts, please write on the comment box, okay. Thank you so much, and yeah.